Standard form of a quadratic, it's an expanded form, so ax squared bx plus c. Even if you only see one or two variables, the other two or one are there. It's just they're zeros, okay? All right, how to find and locate the vertex. You have to use this formula. It's non-negotiable. You cannot go opposite h, follow k, because there's no h, k here. It's a, b, c, okay? All right, so look. A is positive 2, B is positive 8, C is positive 5. Okay, so find the vertex. So in that case, what's the value of x? It's at minus b over 2a. So if I want to find your vertex, and this is your point, right, your x, y, how do I find this? It's that minus b over 2a calculation. So I get minus the b value is 8. Remember, if it was a negative, it would go, another negative would go inside of there. A lot of students kind of will take, like, say if it was negative 8, they would just write negative 8, but you actually switch the sign. Okay. All right, 2a, 2, and the a value is 2, and so it's 4. Negative 2, so half my vertex is known. Negative 2, and then I have to find out what the y value is. But that's easy, right? It's just input, output. Take that negative 2, make it your input by substituting it into your original function. Don't change anything. And so this negative 2 is going to get put here and here. Keep going. Okay, so if I throw in the negative 2 here, again, just be really good with the calculator. For those of you using your phone, I get it, especially if a bunch of kids are sneezing and everything, but you want to know how to use your little negative symbols. Oh yeah, I didn't even use parentheses. And parentheses. So what you see is what you type. And so I get negative 3. And so that is my vertex. And then if you want to solve it by hand, you can. And so there's my negative 3 as well, right? Okay, when you find your vertex, oh, so all my work is here. So here's my work, all right? All of this would go right here. So this was negative 2. Where's vertex? Oh, it's way down here. Can you see it? Negative 2, negative 3. Here's the vertex, you guys. Okay, what's my a value? 2, and is that number positive or negative? Positive, right? So it's going to be concave up, right? It'll be up. Oh, I guess I can put that there. Maximum or minimum point? Right? This is your vertex. Is that a minimum or a maximum? Minimum. Yeah, it's at the bottom, right? Not the top. Remember, the point is the same as your vertex, so it's negative 2, negative 3. What is the value? It's, well, before I would tell you was the k value on vertex form, but it's just the y value of the vertex. It's that same number. And then your axis of symmetry, I know in the vertex form I would tell you x was equal to h. But here it's x equal, and it's the, here, let's grab different colors, let's see. It's the x value to your vertex. So you can see. Yeah. So the vertex gets repeated for the minimum point, but the minimum value is just the y value of the vertex, and then the axis of symmetry is the x value of the vertex. Okay, so now if we build our table, remember your vertex goes in the middle, and then, okay, do you guys want to go 0, -1, -2, -3, -4? You want -4, -3? 0. Okay. And so as long as they're equal distant, they'll have the same. Oh, why did I clear it? 0. Oh yeah, it's just going to be 5, but let's type. +5. Yeah, you can see. All right, so I got 5, and then -1. And then just plot it. And then if you wanted your axis of symmetry, it would be going through here. And yes, of course, we're going to find the inverse functions to this. We'll also find it, but we'll have to review factoring in order to do it. But yeah, we'll review that. All right, so then you fill out the right side. Oh, there's a shift at the bottom. I just saw that. Oh, it goes for both. What do I do? I'll just here. Okay, what's my horizontal shift? Right or left? Left, how many? 2. And what's my vertical shift? Down 3, yeah. And then I guess I'll do that one for this one. I didn't see that till the end.